Hello, welcome back to part four, Fresh Approach to Teaching Optimization from Deterministic Optimization to Sequential Decision Problems. This is a new approach to teaching optimization. Now, when we started the talk, I highlighted these two titans of optimization in operations research. George Dantzig on the left. Conventional thinking is that linear programming, popularized by Dantzig, is a powerful tool widely used for many applications, which it is. Dynamic programming, pioneered by Bellman, is elegant theory, primarily for PhD students and with limited applicability. But what I've found over my career is linear programming is useful, but only on a narrow subset of decision problems, and by the way, most of these are sequential. By contrast, sequential decision problems are virtually universal, something we all encounter every day. But Bellman's equation is rarely used, limited to a small number of applications. Given this, I claim it's time for us to change how we approach optimization. So the biggest mistake we make in teaching optimization is today we teach students sophisticated tools and tell them to go look for applications in the real world. In practice, our students will not get to choose the problems. Industry chooses the problem, and our students need to have the tools to solve them. We do not need to teach students algorithms such as simplex, integer programming, nonlinear programming, which are readily solved using computer packages. These packages have become very, very good. We do need to teach them how to create and interpret the models that are solved using these packages. Now, I like this skill cycle. Upper left-hand corner, imagine that's any problem domain. I've depicted a business problem, but this could be in a health setting or energy or finance. Now, to the right, I've created a corner which I call framing the problem. And this consists of three dimensions that have to be identified and described: metrics, decisions, and uncertainties. Now, once we understand metrics, decisions, and uncertainties, there's going to be a lot of decision problems where that additional clarity will allow you to solve the problem. But to the extent that you feel like you do need to do some computational work, lower right-hand corner, here's the universal modeling framework. I can model any sequential decision problem using this modeling framework. And by the way, this is work that would be done by typically people with an engineering background, such as industrial engineering. And this is the community that would talk to the theoreticians. So this is where theoretical challenges may arise, and so this should be largely invisible to people actually solving problems. Now, next step over is software, and by that I mean covering both the front end, the back end, and the decision engine before we get back to describing the problem. Now, I've got a new series of books. My newest book is coming out fall of 2025, Bridging Decision Problems, Volume 1, Framing the Problem. So this is a monograph, about 130 pages, all built around the three questions: what are the performance metrics? What types of decisions are being made? What are the sources of uncertainty? Chapter 2 of the book lists maybe about 10 different applications, and for each one, it takes a crack at answering these three questions. What this has done is this is designed for a non-technical audience. This book uses no mathematics, and it's designed to overcome the bias that we have where people who do have training in methodology will go out to the real world, and the questions they're asking are heavily biased toward the tools that they have. This is designed to train a group of people who are not going to actually know the details of specific modeling and algorithmic approaches, but they need to ask the questions that would help that community build those models. So it's designed to avoid the bias of methodological experts, but to draw out and get the information that is needed. Now, second book that came out in 2022, Sequential Decision Analytics and Modeling, uses a teach-by-example style. Every chapter models a different problem using the universal modeling framework. So here we see, other than chapters 1 and 7, which are more overview, every other chapter is a different application, but following the same style. So this is very easy to skim. In fact, you may go through and say, gee, I'm really just interested in how you're using the universal modeling framework. Each one has a section on how to model uncertainty, and there's a section dedicated to designing policies for making decisions. Chapters 2 through 6 will end up giving you a tour through all 4 classes of policies. Chapter 7 pauses to say, hey, let's look back over the first 6 chapters and see what we've learned. The remaining chapters tend to be more complex problems. Now, for those who want to actually write software, my graduate level book that came out in 2022, Reinforcement Learning and Stochastic Optimization, this is aimed at a graduate level audience. At Princeton, the last time I taught this course, I had 50 graduate students from 10 different departments. So this may be technical. It has the technical level of anybody who has to write code. So there's no gratuitous mathematics in this. This is absolutely focused on modeling and algorithms. Now, I also have a book for instructors. So this book is aimed at people teaching introductory courses in optimization. Now, it was motivated by looking at the course at Princeton that was teaching, it was generally viewed as the linear programming course. What I do here, topic 1, I start with machine learning. Now, it turns out machine learning is not only very familiar to people, I mean, now the AI is everywhere, but it also teaches people the idea of looking for good functions and how to do parameter tuning. Topics 2 through 6 all involve some sort of sequential decision problem for relatively simpler decisions, the kind of decisions that we actually see in our day-to-day life. Now, each one of these involves some sort of parameter tuning, so this builds off of topic 1. Now, I don't get to topics like linear programming until topic 7. Now, I cover both linear, integer, and then nonlinear programming, and I cover each one 2 ways. First, for a classical static model, and then in the context of a sequential problem. Because when you have a problem like assigning machines to tasks and it's a linear program, you need the technology of linear programming. We use linear programming at a point in time, but we have to understand that tool is applied over time, and it's the performance over time that is the true objective function. So I'd like to thank everybody for attending the talk. Once again, I refer you to my general information resource page, tinyurl.com/SDA links. This page includes links to videos, books, both introductory and advanced, as I've shown you. I have a section on Introduction to Optimal Learning. This is for the discrete choice problem. I have a web page dedicated to how to teach this at various levels, including weekly seminars. There's educational web pages on topics like state variables, which are very confusing. And then I've created a Google Docs web page for a series of my LinkedIn posts that I think are of higher educational value. Thank you, everyone, for attending.